Hello everyone. So today we are going to start solving the CP31 sheet which is provided by TLE eliminators. So we are going to solve this sheet thoroughly. So today we are going to solve the first question, which is known as Halloumi boxes. This is the link of the sheet. You can access it by this link. So this is the first question. Let's go. Okay. So I have this question in my whiteboard. So let's start by by understanding the question first. So let's read out the question. The Theophanes is the busy after his last contest, and now he has to deliver many halloumis all over the world. He stored them inside n boxes, and each of which has some number written on it. So halloumi has n boxes in which he has some number written on it. Let's say he has five boxes and he has some number A1, A2, A3, A4 and A5 written on it. Okay. So he want to sort this them in non-increasing order. Non-increasing means increasing order. Non-decreasing means increasing order based on their number. However, this machine works in a strange way. It can only reverse any subarray of boxes with length at most k. Subarray means let's say I have an array of 1, 4, 5, 6, 7 and 10. This is the subarray of 6 length. Subarray means the continuous consecutive elements, that the continuous range. Suppose this is one subarray, or this one is one subarray. Okay, so they are saying that at most at most k means we can choose the subarray with length at most k and reverse it. Okay, this is the operation we can perform. And what is our goal? To find if it's possible to sort the boxes with any number of reverses. Okay, so reversing subarray means choosing two indices I and j, where I should be greater than 1 and j should be greater than 1, and should be less than, both of them should be less than n. And changing the array a1 to an to a1, I mean, uh, I will explain this with the help of this. Suppose this is the subarray. I choose this subarray and want to reverse it. So the new array will be 1, 6, 5, 4, 7, and 10. So we chose this as the I, this as the J, and we decided to perform the operation on this subarray. So we reversed it. Okay. So what is the input for this problem? So input for this problem is, the first input is number of test cases. And the second input will be n and k, where the n is the number of boxes and k is the length of the maximum subarray. And second line gives the n integers as the all n elements of the array. Okay, so what is the input? N, k, and a1, a2 up to an elements. Okay, so let's read the further question. So what is the output? For each test case, out of the t test cases, we have to print yes if the array can be sorted in increasing order, and no otherwise. Okay, so we can perform this operation, that we can choose the subarray of length at most k. At most means, suppose the k value is 4, so I can choose the length as 1, 2, 3, or 4. Okay, so let's take the first test case. So first test case is 3, 2, 1, 2, 1, 2, and 3. So I can choose this is the k, this is the n, this is the k. So I can choose the length as 1 or 2. So I decided to choose the subarray as 2. So I can choose this subarray or this subarray of length 2, but the array is already sorted, so I will directly print yes. Let's take the next test case, that's 31999. So I can choose the subarray of length maximum 1. So I can choose the subarray of length 0 or 1. So I can choose any subarray of length 1, but it's already sorted, so I will print yes directly. Okay. So let's take third test case. That is 4, 4, and 6, 4, 2, and 1. So here k is 4. So I can choose the length as 1, 2, 3, or 4. So I decided I will decide to choose length as 2. What is the sorted format of this array will be 1, 2, 4, 6. Okay. So I have to bring 1 to this position. Okay, so I can, we have the freedom to perform the operation any number of times. So I can choose this subarray. Then the array will be 1, 4, 1, 2, as the operation is to reverse the subarray. So now I will choose this subarray of length 2. Then the new array will be 1, 4, 2. Now I will choose this subarray 1, 6, 4, 2. Same for this two. Then the one is at the desired position. So I will choose this. So I can bring two to this position. So I will choose this subarray. 1, 6, 2, 4. Now this subarray 1, 2, 6, 4. Now I have to bring 4 to this position. So I will choose this subarray 1, 2, 4, 6. So the array is sorted. We don't have any restriction to choose how many number of operations we can perform. So uh, a quick observation from this test case that if if k is equals to 2, then we can sort any array. We can sort any array. Why am I saying this? Because if the k is 2, I can put any element to any position, as we saw in the test case. Let's see for the test case as well. 4, 3, 10, 3, 8, 30, and 14. The sorted format of this array will be 3, 10, 14, and 830. That means increasing order. So I have k is as equals to 2. So I can choose the length as 1, 2, 3. I will choose 2 to support my prediction, support my observation. So I have to bring 3 to this position. So I will choose this subarray and reverse them as per the given operation 3, 10, 8, 30, and 14. So I have to bring 14 to this position. So I will choose this subarray and reverse it 3, 10, 14, and 830. So it's sorted. So as per the observation, we can conclude this statement that if k is equals to 2, we can sort any array. So we can come to the conclusion that as per the given question, the value can be at most k. At most k. That means k, that means less than or equals to k. Any value between 1 to k. So if k is greater than or equals to 2, we can sort any array. So if with this condition, we will directly print yes. The ultimate goal of this question is to, if we can sort the array, if we can arrange it in the non-decreasing order, which means increasing order, then we can print yes. Now, as per the question, the range of k is from 1 to 100. So now we got this observation, if k is greater than or equals to 2, we directly have to print yes. But what if k is equals to 1? Then what should we do? Let's take one test case where n is 5 and k is 1, And let's take the test case as 3, 100, 4, 6. Here we can choose at most one length subarray. That means we can choose one length subarray. That let's say 100 I chose and I reversed it. The next array will be same. Okay. So we can conclude from this observation if k is greater than equals to 2, then we definitely can print yes. But if k is equals to 1, then we have to check if array is already sorted. 1 minute. If array is sorted, then we don't have to perform any operation. Then we can directly print yes. But if array is not sorted and the k is equals to 1, then we have to print as no. So let's write the conclusion from this question that if k is greater than equals to 2, then we will definitely print yes. But else if k is equals to 1, then we will check if the array is sorted. Then if it's sorted, then yes, otherwise no. So let's code this. So I have done some competitive programming setup for my laptop. I will make another video for it. Just bear with me for this moment. Okay, so I have passed the test cases. These are the same test cases as per the question. So let's write code for it. And this is the basic template. Okay, so let's take the first input as the number of test cases. So the number of test cases are t. Let's take the number of test cases in the variable t, and we have to perform the t number of test cases. So I will write the simplest format of the code so that you can easily understand it. So this loop will run for t times, and we can compute our t test cases, t number of test cases. So we have to take input for the individual test case now. So the first will be n and then k. So let's take first input as n and the second test case as k. After that, we have to take input of n elements. I will choose vector for it of n size, and I will take the input of n elements in the vector. So now, as per the conclusion, if k is greater than or equals to 2, then we will print yes. So if k is greater than or equals to 2, then we will print yes. If else if k is equals to 1, then we will check if it's sorted. If sorted, then yes, otherwise no. Let's write it down in code. If k is equals to 1, then we will check if the is sorted. This is the inbuilt function. If you want to use for it to check if the vector is sorted or not. If it's sorted, then see out yes. Otherwise, see out no. You can choose this, use this inbuilt function as well. Otherwise, you can use the custom made function which you can use. Let's take the check for the size, and then this function will also work, but if you don't want to use this, you can make your own one. Okay, check we have passed this vector, and we will take it as a reference. We'll check for first for the size, then afterwards we can check if there is we can make our own function in which we can check if its array is already sorted or not. If any element, any preceding element is greater than the succeeding element, then we will return false. Otherwise, we will return true. Okay, so you can choose this as well. Now let's run this program and check if we can get this expected output as per my program. Okay, so it's passed. Okay, so this is the expected output and this is the received output. It's same. So now let's submit this code. Let's submit it here. It's in queue. Let's refresh the page. It's running on first test case. Let's refresh it. Yes, it got accepted. So thank you. You can provide any feedback in the comments. Thank you.